Hey everyone, welcome back to Brainstorm. This is Python for NCEA. Now in this video we're going to be going over an introduction to the fundamentals of Python. So we're going to be going over the fundamental data types. Now before we can do that, we need to go over how we write and how we run our code. So given that we've just installed Python, if we search for the letters IDLE, it's going to pop up the Python idle. If we enter that, it's going to come up with this thing called the idle shell. Now, what we want to do is we want to go File, and then a new file. Then it gives us this kind of blank canvas here. So, if we save this now, we can save it wherever, and we can call it whatever we want. Let's call it hello. Then we want to save it with the .py extension. And this says hello.py, and this tells us that this is, well, a Python file, right? So, yep, save as type Python files. So, if we save that, this is now a Python file. So whatever I write in this file, if I click F5, so I can click F5, or if I click run and then run module, any code that I've written in here is going to run in the idle shell. So if I save my file first and then I click F5, the code runs in the idle shell here. So any output that my program has, or any errors that our program has, are going to come up here, right? Alright, so now that we've learned a little bit about what the idle does, let's get into the actual coding part. So the first thing we're going to take a look at is called code commenting. Now the premise of code commenting is that, well, if I was to give my code to another person, how can they understand my code, right? So we write code comments to explain what different pieces of code do to another person. Now, code comments are not read by the idle, essentially, when we run the program. Okay, so when Python goes to execute our code, whatever we write in the comments are not going to be executed in the actual program. So there are a couple ways that we can comment our code. The first way is by using a hashtag. So whatever I write in the hashtag won't be run by the code. So I could write hashtag this is a comment, right? And this is what we call a single line comment. So if I write something on the next line, it's not going to comment out, right? Because hashtags are a single line comment. The way we can do a multi-line comment is by doing 3 apostrophes. So we could do 1, 2, 3, and then everything under the apostrophes is now commented out, right? So you can see I'm writing multiple lines here, and they're all commented out. Now, once we want to end our comment or our multi-line comment, we need to end it with 3 more apostrophes. So 1, 2, 3. And as you can see, everything else now has gone back to code. An alternative to this is to use quotation marks. So we could do 1, 2, 3. Oops, sorry. 1, 2, 3. So we've used 3 quotation marks. Now everything in here is comments. And then we can use 1, 2, 3 to end our multi-line comment. So note that, remember what I said, anything that we write in comments is not actually run by our program. So if I go ahead and save this and I go and run our file, so run module, you can see that nothing actually happens. That's because this entire program here is all comments, right? So that means that nothing is actually interpreted by our program. All right, so let's take a look at our first data type. And our first data type is called an integer. Now you might remember or recall something about integers from maths. An integer is any whole number. So for example, we have the whole number 1. This is an example of an integer. We have the whole number 2. That's an example of a whole number or an integer. We can also have negative numbers. So we can have -4. We can have -900 or -9,000 or -900. We can have -10,000 and so on and so forth. Now, integers range from -infinity to +infinity. So any whole number you can think of is classified as an integer. Now, would -3.14 be an integer? The answer is no, right? Because we have this 0.14 here. That means it's a decimal and not an integer. So therefore, yep, we cannot classify this as an integer. So we've got all these numbers here, with all these integers. Let's save our program. So Control S. And run it and see what happens. Well, you can see that nothing happened again. Now you might be thinking, well, why is that? We've written something that's not a comment, but nothing's happened. Well, essentially, if we want something to show on the idle shell, we need to print it to the shell, right? So if we want some kind of output to a shell, we're going to use something called the print function. Now the print function is one of the fundamental things of Python. So essentially we write the words print for print, and then we have our opening and closing brackets. And essentially whatever is inside these brackets here is what's going to go onto our idle shell here. So for example, if I want to print the integer 1, I just put it inside the brackets. If I save now and click F5, well, now we see 1 has been outputted to the idle shell. So that's pretty cool. Let's try and print negative 9,000 or negative 9 with how many zeros is that? So that looks like negative 9 million, right? Let's print that out. And as you can see, we've got 1 here and then negative 9 million there. So it's printing exactly these two integers here. Now I'm going to introduce you to another function that you probably don't need to use, but it's called the type function. So it looks like this, and essentially whatever I put inside the type function, it's going to tell me what the type of object is, right? So if I put 1 in there, it's going to tell me, well, this is an integer. So let's do that, for example. So I put type 1, okay, and because I want to output this onto my shell, I'm going to have to print it. So print, and remember whatever's inside our print parentheses is printed. So I'm printing the type of object, or the type, or the class type of this number 1. So if I print that there, you can see that it tells me, well, this is of class int, which is an integer, right? So it's telling us that 1 is an integer. All right, so let's look at what floats are. Now, floats are similar to integers in the fact that they are numbers, but floats stand for floating point numbers. So we're writing anything that's a decimal is of the class type float. So we have numbers like 3.14. We have numbers like 3.9999. We have numbers like 2.5. These are all floats because they have a decimal point or a floating point. So let's try and print one of these to the shell. So print, and then whatever's inside my brackets gets printed. So let's print 3.14. If we save that and click F5, 3.14 gets printed. Now let's just check that this is actually of the float type. So remember, if we want to check what the type of the class type of one of these numbers is, we want to use the type function. So we type type, we put our brackets in, and we want to check the type of whatever's inside these brackets. So we're going to put the type of 3.14. We want to see if this is a float, if this is an integer, or maybe even something else. Now, remember, if we want to get it to show on the screen or on the idle shell here, we need to print that. So I'm going to write print, and remember that whatever's inside our brackets here is what's printed. So I'm going to move all of the stuff here inside our bracket. So I've just cut and pasted it into there. Cool. So save that, click F5, and you can see this is of the class float. So 3.14 is a floating point number. Now, something about Python is that we could use that as a calculator, right? So I can add numbers, I can subtract numbers, I can multiply numbers, and I can divide numbers. So let's try that out. So if I take the number 2 and I add it with 5, 2 plus 5, right? That should give me an output of 7 if I print that. So let's put it in the print statement. So print, I got my open bracket and my close bracket. So this shouldn't print just the statement 2 plus 5, but it should actually compute what 2 plus 5 is and print that out in our idle shell. So we expect that we will have 7 coming over here. So save that and click F5, and as you can see, we have 7 showing up down here. We can also do subtraction. So let's do 2 minus 5. We would expect that to print negative 3. Let's do print 2 times 5, and let's do print 2 divided by 5 while we're at it. So this should compute all the values of 2 plus 5, 2 minus 5, 2 multiplied by 5, and 2 divided by 5. So let's click, or we'll save it and click F5. And as you can see, it's computed all of these values. So it's 2 plus 5 is 7, 2 minus 5 is negative 3, 2 times 5 is 10, and 2 divided by 5 is 0.4. Now, let's have a think. Are these numbers integers or floats? So 7 is a whole number, so that's an integer. Negative 3 is a whole number, so that's an integer. 10 is a whole number, so it's an integer. And 0.4 is, has a decimal point or a floating point, so it's a float. Now, the way Python works is it does BEDMAS, right? So essentially, the order of operations, so it computes anything in brackets first, followed by exponents, followed by any dividing, any multiplying, then followed by addition, and then followed by subtraction. So if I have a statement like print 2 times 5 plus 3 divided by 6 minus 2, it's going to compute 2 times 5 and 3 divided by 6 first, and then it's going to add them and then subtract 2 finally. All right. So if we run that, that comes out to 8.5. Now, I did skip over exponents, right? So if we want to write an exponent, because it's a little bit more not intuitive, you might think that we might want to write this with a angle bracket like this, so 2 to the power of 5. Well, let's run that and see what happens. Well, it gives us 7, which is not 2 to the power of 5. So how do we do it? Well, we need to do 2 asterisks. So the double asterisks mean we want to raise 5 to the power, we want to raise 2 to the power of 5. So if we check that now, we get 32, which is the value of 2 to the power of 5. Okay, now the modulo operator essentially does division, and it prints out or gives out the remainder if there is one. So for example, the modulo symbol looks like the percentage sign. So whenever we have a number, so if we have a number here, modulo a second number, that gives the remainder. So for example, let's do 6 modulo 4. Now we know this is going to give us 1, and we're going to have 2 left over. So it's going to be 1 remainder 2. So the modulo operator is going to give us 2 if we print it. So let's print it. So print, we have our open bracket, then we have our close bracket at the end of the statement. Now let's save and click F5, and you can see that 2 was left over. So the modulo operator can be pretty helpful in some scenarios. Now let's take a look at the round function. So what the round function does is it rounds a decimal number up or down, right? And we can specify the amount of decimal places that we want to round to. So if we have the number, let's say 5.44446, and we just write round, right? What this is going to do is it's just going to round it up to the nearest, I believe, the nearest whole number. So this is going to round down to 5. So remember that if we wanted to get it to output here, we need to print it. So let's use the print function, just like this, save it and click F5. And yep, as you can see, it's rounded it down to 5. Now, we can use the round function and specify how many decimal points we want to round to. So if we want to round it to 2 decimal points, we're going to put a comma inside the brackets. And then we're going to put a 2 for 2 decimal places. Now, if we save that and click F5, we see that it rounded to 2 decimal places. So that's really interesting. All right, so next we're going to look at strings. Now, as the name suggests, strings are a string of text. So the way we represent that is with quotation marks. So just one quotation mark to start the string and one quotation mark to end the string. So whatever I put inside these quotation marks is a string. So I can put hello there and maybe an exclamation mark. And this is what we call a string. So if I want to get this into my idle shell, I need to print it. So I use the print function. So print, open bracket, and a close bracket at the end. And now if I click F5, hello there prints the screen. So now we're getting text, and that's really interesting. We can also print numbers. So we can represent numbers as a string. So if I put the quotation marks in and I put a number, well, it's still going to print the number to the screen. But note that now it's a string type. It's not an integer, it's a string. Okay, so this is the ASCII representation, I guess, right? So if I print the type, so let's go print, and if I want the type here, of this string of 8 here, I can write type in here, and whatever's inside the type is going to return what type of object it is or what type of class it is. So if I want the type of this here is a string, so we're going to get the type of 8 is a string, and so it's going to print out that this is of the string class. All right, so if we execute that, we see this is the class string, right? But if we just print, so if I was to copy and paste this again, oops. So I copy this and paste it. And instead of having the quotation marks, I just put 8. Now if we execute this, the first one is a string, but the second one is an integer, right? So these quotation marks make whatever is inside the quotation marks a string. But if there's no quotation marks, then it's an integer. Okay, so that's really important to keep an eye on. Okay, let's take a look at what happens if I try to print a string without putting quotation marks. So if I write hi there in here without the quotation marks and I try to run it, well, we get an invalid syntax. So it won't even let me run it here because the idle is smart enough to know that, hey, you probably need quotation marks here. So if we put our quotation marks here now, and we save it, click F5, it runs just fine. Okay, now let's move on to variables. Now variables are a very important part of programming. They're going to make your life a whole much more easier. So what is a variable? Well, you can think of a variable like a box. We can store multiple different things inside our box, but our box still remains the same, right? So a variable is like that. We can store different numbers or different items inside the variable and then replace the variable in different places, and it just shortens our code and makes it more easier to understand. So what do I mean by this? Well, how do we set up a variable? Well, let's call a variable, let's call it, let's just write it as variable, and let's set it equal. So the equal sign means set whatever's on the right hand side of the equal sign into our box, or into our box called variable. So if let's just put a string in here, so remember strings have quotation marks, and let's put this is my first variable. Okay, and we've got a variable here now. So whenever I use the word variable in my code, it's going to replace it with the string, this is my first variable. So that's pretty handy, right? So if I print this now, so I want to print the variable. I don't have to print this whole text out. I can just print the word variable and it's going to replace it for me when we execute the code. So I'm going to put print variable. So this is the name of my variable here. And I save it and execute it. And now you can see instead of printing the words variable, it prints this is my first variable. Let's make another variable. Let's call it my second variable. And let's give it an integer. Let's call it 8. Now, if I write my second variable again, and I set it equal to 9, well, when I go to print my second variable, what do you think it's going to print out? Well, we wrote initially that my second variable was 8, and then we wrote that it was 9. So what it's going to do is it's going to overwrite this 8 here with this 9 here, because essentially Python reads the program from top down. You can think of it at this stage, it reads the program from top down. So as a result, it's going to overwrite the 8 here with the 9 here. So when I print my second variable, we should see a 9 coming down here. Oops, sorry. F5, save that, then we should see a 9 here. Now, note that my second variable is a number. So if I print my second variable added with another number, it should still calculate that just fine. So if I add 10 to it, it should print out 19. Let's give it a go. And yes, it does print out 19. Now, note that we shouldn't try to add strings with integers or it's going to give us an error. So let's try that out. Let's try and print variable plus 10. So we're going to add text and a number together, and of course we know that that doesn't work. Let's see what the idle does. So click F5, we get a type error, right? So we've got this nice red text which tells us we've got an error here, and you can see the type error, we can only concatenate a string to a string. So essentially what this is saying is, hey, this is a string here, and you cannot add a number to it. That doesn't make sense. Now, the way we name our variables is quite important, all right? So Python has naming conventions when we write our variables. So the first convention is that we never start a variable name with a number. And the second convention is that, well, when we have different different words that we want spaces, and we should use an underscore to represent that. So we never want to start a variable like this. So 1 underscore hello, right? That's not a good convention, right? The second thing is that when we have two different words, so if I wanted to call a variable hello world, I wouldn't write hello world like this. I need to have an underscore here. Now, it doesn't mean that your code's not going to run. It's just a convention which makes our variables easier to read. Now, the last thing is that our variable names should relate to what we're storing inside our variable. All right, so we don't want to put random variable names in there. We want to put names that actually make sense. So we've put hello world here. So that's the name of a variable. Let's set it equal to something that makes sense. So we might want to choose the string hello world, right? So the name makes sense for what we've stored inside our variable or inside our box. Finally, let's look at object type conversion. So you might remember from before where I said, well, we can represent a number as a string, but our number can also be represented as an integer or a float, for example. So if we had the number 10, so this is an integer, I could also represent it as a string. So I could just put the quotation marks and put 10 inside, and now this is 10 represented as a string. I could also represent 10 as a float. So if I put 10.0, this is still effectively 10, right? I've just got a 0.0 here. Now, what would happen if I have one of these data types and I want to make it one of the other ones? So what if I had 10.0, for example, and I wanted to make it the string version of 10? Or what if I wanted to make it the integer version of 10? We need some kind of way to convert from one to the other. So in order to do that, let's start by making a variable called myInteger. So myInteger is equal to, and let's choose an integer. Let's choose the number 500. Now, let's say I want to convert that to a string. So let's do integer to string. So this is a single line comment, remember, so my code's not actually going to read this. Now, I want to convert it to a string. So let's come up with a new variable. Let's call it myString, and let's set it equal to, now we want the string version of this. Now, of course, we could just put the quotation marks and write 500 in there, but that's cheating. We want to convert this actual integer here into the string. So the way we're going to do that is we need to call a function called the string function. So that's str, and then we've got the brackets here, and essentially anything inside the brackets here is going to make it a string. So we want to pass in the variable myInteger. So if I put myInteger in here, when we call the string function, so whatever's inside of the parentheses here is going to become a string. So it's going to call myInteger. And remember that we've called myInteger is a variable, and inside the myInteger variable is the integer 500, right? So essentially, this is the same as the string of 500, and that's going to give me the output of 500 as a string. So pretty cool. So if I print my string, and then I print the type of my string, we should see that it prints 500, and then we should see that it's also a string. So let's F5, and yep, 500, and it is a string. What if we want to now convert from, let's say, a string to an integer? So let's call a new variable called myString2, and let's call it, how should we start our string? Let's write the number 700 represented as a string. And so if we want to make it an integer, we're going to do something very similar here, but we're going to write int. So myInteger2 is equal to the int, and whatever's inside int function, and whatever's inside our brackets is going to be turned into an integer. So I want to make myString2 an integer. So I'm going to pass in myString2, and now if I print myInteger2, and I also print the type of myInteger2, I should get that we should get 700 here as the integer, and the type should tell me that it's of the class integer. So let's execute that. And as you can see, we've got 700 here, and it's of the integer class. Now, we don't actually need to worry about what the class means at the moment. We're going to look at that way down the end. We just need to know that it's of the integer type. Now, it might be interesting to note that, well, let's create another string called myString3 and let's put some text in it. Let's say hello. What do you think would happen if we try to convert this to an integer? So if I put the int function here and I pass in myString3, which is the same as the string hello, and now I try to execute the program by clicking F5, well, now we get an error, invalid literal for int with base 10 hello. So essentially what this says is, well, I can't make an integer out of text. That doesn't make sense, so I'm throwing an error. So we cannot do that. What about if I want to convert a float to an integer? So what's going to happen? Float to integer. So right, so let's create a variable called myFloat, and let's set it to 5.5. Now, if I want to make this an integer, we're going to do essentially the same thing as before. My integer 3, so this is the name of my third integer, and let's set it equal to the float, the integer version of my string, of my float, sorry. So we want to make this float the same as an integer. Now, let's see what happens, right? Because we know that a float is not an integer, so what's going to happen to the 0.5? Is it going to round? Is it just going to truncate the number, or just completely delete this 5? Let's see what happens. So I'm going to print my integer 3 and run it. And as you can see, it's just printed 5. So it didn't round up in this case. So what we can say is that when we write the integer myFloat here, it truncates the number, or it just removes anything after the decimal point. Now, if I convert an integer to a float, integer to float, let's create an integer, so let's call it myInt is equal to 87, for example, and I want to make it a float, so let's just print the float of my int. So I didn't create a variable for it, so I'm not storing this value anywhere. I'm just printing it directly. So the float version of my int, it should print 87.0, right? Because this is the same as the integer version of the number. Alright, now at the end of every video, I will have application questions, right? So the purpose of these is to see how can we use what we've learned in real world scenarios, or how can we apply them in our internals, or our technological outcomes, sorry. So the first question is a very basic question. We say store the words hello world in a variable called myFirstVar. And then we want to print the variable. So there's no necessarily any input. I don't want to show you the input because they'll give the answer away, but the output should be the string hello world. So we want to, let's break it down. So we want to put the words hello world in a variable called myFirstVar. So let's just write the words hello world. Now these are going to be of the string type. So we have the quotations, and then we put hello world with an exclamation mark there. And we want to put it in a variable called myFirstVar. So remember how we set up our variables? We write the variable name, myFirstVar, and we set it equal to the string, or equal to what we want inside the variable, which is hello world. Then we want to print the variable. So we're just going to simply use the print function. So print, and then we want to print myFirstVar. Now, if I save this, essentially when we go to print, it's going to print myFirstVar. It's going to come up to here and see, well, myFirstVar is the same as the string of hello world. So I'm just going to print hello world. So if I click F5 to execute the program, hello world runs here, and this is the actual suggested output. So we've done well there. Let's move on to question 2 now. Store the value of 10 to the power of 32 in a variable called myFirstInteger, and then we're going to print the variable. So what I'll do actually is I'll pause the video here, see if you can work out how to do it, and then I'll go over the answer. Alright, so we want to store 10 to the power of 32. So how do we do that? In programming or in Python, we write 10. Now, to the power of, or exponents are represented by 2 asterisks. So 10 to the power of 32. And we want to store that in a variable called myFirstInteger. So let's write a variable, my_firstInteger, and we are setting that equal to the value of 10 to the power of 32 here. Then we want to print that value. So what we're going to do on the next line is use the print function and put inside our brackets the variable name, my first integer. So hopefully that wasn't too hard, and that should compute the value of 10 to the power of 32. And if all goes well, we should get the same answer as this here. So let's click F5, and well, the numbers look pretty much the same. If I, let's see, yep, exactly the same. So we've gotten that correct as well. Let's look at the final question. This one looks like it might be a little bit harder. So the area of a circle is given to be a is equal to pi multiplied by r squared. Given that pi is equal to 3.14, we want to calculate the area of a circle with a radius of 3 centimeters. We're then going to store the value in a variable called myArea. Truncate any decimal points and print the variable. Okay, so we should get 28 as the answer if it all goes well. So how are we going to do that? Well, we need to calculate the area first. We're going to then need to truncate any decimal points and then print the variable. So have a go and then see how we would answer this. All right, let's look at the answer. So we know that we need to store all of this in a variable called myArea, right? So the first thing I'm going to do is set up the variable. So myArea is equal to all of the stuff in here. So the value of pi, and we said that pi is equal to 3.14. So in this case, we're just going to put 3.14, which is a float, right? That's multiplied by r squared. Now the radius was given to be 3 centimeters. So 3 squared. So in order to do a squared value, we're doing 3 to the power of 2, and that's done by 3 to the 2 asterisks and then 2. So this calculates 3.14 times 3 to the power of 2, which is the same as this here. So let's print myArea and see what happens. Print myArea, save it and click F5, and it prints 28.26. But we've got 28 here. So what's going on? Well, remember that we need to truncate any decimal points and print the variable. Now, there are a couple of ways that we can truncate the number. We could use the round function, and then we could round down to 28. So if we go myArea is equal to, now we use the round function, and remember we're rounding down whatever's inside those brackets. So if I put myArea in here, well, we're essentially overriding myArea. So we're overriding this number with the rounded down version of this number. So we got this, myArea currently is 28.26. So instead, we're going to override it with the rounded down version of 28. Okay, so if we save this and run it, sorry, I need to actually print it, remember? So if we want something to show on the idle, we need to print it. So we're going to print myArea now. And we should see it goes from 28.26. It's going to round down to 28. Now, another way we could do this is if I delete this code here. So instead, if we want to truncate any decimal points specifically, we could use the convert from a float to an integer. So in order to do that, I'm going to say myArea is equal to, and we want to truncate, so we're going to convert from a float to an integer. So the int and whatever's inside the brackets is going to be turned into an integer. So I want myArea, or I want all of this stuff, which is called myArea, to become an integer. So I'm just going to put myArea in there. If I save this and run it, it should give me 28. So remember, I need to print it. So print myArea, save it, and let's run it. And you can see it gives me the exact same output as before. I get to 28 here. Awesome, guys. Thanks for watching this introduction to Python. Stick around for the next video. Cheers.